Hello. Hello.
Hello. Hi there.
Hi, how's it going?
Hi, pretty good. So we have about an hour. So we'll
Cool,
spend 45 minutes working on an interview question or two together.
cool.
And we'll save the last 15 minutes or so to share feedback. And we'll just use the next 5 minutes for setup. Uh,
Cool.
so, um, I have been at Google for about 6 years, and before that, I worked in ed tech for a while. Could
Awesome.
you could introduce yourself if you'd like, or you could just tell me a little bit about where you are in your interview process.
Yeah. I am currently I've been working in robotics, and mostly a lot of platform type stuff. Also, I've done a good bit of motion planning as well. I'm targeting a bunch of C++ roles at self-driving car companies. There's a very famous one that everyone's heard of that was spun out of a FANG company, and they've asked me to do the interview in C++. It's for an L5 role. However, they have a reputation for kind of down leveling, so I'm hoping to give a little bit of
Mhm.
L6 signal during the interview as well. Um,
Mhm.
and yeah, I've got 10 years of experience. I've done successfully in interviews in the past. I team matched at once, and
Mhm.
my current employer is known for having a pretty hard interview loop as well. So I can do it. I just
Mhm.
it's always hard.
Yeah. Okay, sounds great. Cool. Yeah, that makes sense. Okay, so L5, maybe L6, C++. Great. Let's see. Um, is there anything you'd like feedback on in particular today?
Yeah, so one piece of feedback I get is it's very conflicting, but either I'm going too fast and I don't plan things out effectively, or I'm going too slow and it's not urgent enough. So I don't know if you have any thoughts on that. I think I'm going to try and go more on the slow side because it's better to be a little bit slow but have really clear thinking, I think, versus like rushing and solving the wrong problem.
Oh, interesting. Okay. That's yeah, I'll note down that and yeah, I'll keep track of timings and everything.
Thank you.
Um yeah. Okay. All right. I think we can just jump into it.
Cool.
One more thing. Will you be practicing with the execution environment today?
I I'm not sure. I think maybe better if I don't because I believe that they don't you don't run the code during the interview, right?
Yeah, there isn't really one. I think here the other difference is you get syntax error feedback, by the way. So it'll be a little bit
Okay.
different, but
Okay.
yeah. Uh,
Yeah, we can
yeah,
turn
up
off
to you.
the
Yeah.
execution environment. That's good. Yeah.
Yeah. I actually don't think we don't hit run. Uh,
Okay, cool. Okay.
all right. Okay, I think that's everything. So we can get started. All right. So are you familiar with the number of islands problem?
Yes. Yes, I am. Maybe I'll just quickly describe it to you.
Yeah.
Would that be helpful? Yeah, so um, the idea is um, if you have, let's say, a 2D matrix and some of the cells are labeled 0 for ocean and 1 for island, if you have a binary values, um, the sub problem here is that let's suppose you are on a cell that is an island. You could do a breadth first search or a depth first search. Doesn't really matter. Depth first search might be easier, but you search outward from the cell you're on, and you only explore cells that are islands. So if your adjacent cell is a one, you say this is an island, and then uh, you kind of fill it out, and you can add all these cells to your visited set. And then you want to kind of repeat this for all the islands. So in order to find all the islands, you could do a linear scan over the 2D matrix uh, and skip all the ocean cells until you hit an island cell. Then you do this, I guess, like a flood fill to capture the island, mark all those cells as visited, increment your island count by one, assuming you want the count of all the islands. And so you're in the worst case, you're doing a order n by m scan of the whole map, or that's you have to do that. And uh, then each breadth first search is order, I guess, k for the size of the island itself, which would be less
Yeah,
than m. So it'll just be order n times m.
yeah, great. Okay. Let's see. I have a I'm not sure whether you'd like to start with um, a small variant on that or something different and maybe more interesting. Maybe yeah. Okay, let's start with something more interesting.
Sure.
Um, we'll use the same grid where one is land and zero is like the ocean or water,
Hmm.
and lands up, down, left, or right. Um, so um, on this grid, we're given an integer k,
Okay.
where k is the number of days. Uh, so um, what happens is um, each day, any land cell that is adjacent to a water cell becomes water. So could you find the number of islands remaining after k days of erosion? So I'll just give us um,
Interesting.
example here.
Um,
So this is after 1 day. So any land cell that is up, down, left, or right to a water cell, so these land cells will become water after the next day. So
oh, very cool. Okay.
we'll return 4 islands with a K of 1.
Mm. And every day erosion happens once, and then after K days, um, we'll see what we have left. Is that
Yes.
right?
Yeah, that's right.
Very interesting. Let me think about how I might want to do this. So, um, one thought I have is, um, let's let maybe you can, you can, if on the 0th day, you start on day 0, and what you could do is, well, a really simple way to do it might be to like simulate. So then you have the whole map, and then you like iterate over the whole thing k times. So that's like an n times m times k,
Mm-hmm.
and then you simulate the whole process. You simulate the erosion, and then you do an n times m island search that we discussed earlier,
Mm-hmm.
island counting thing. But I think there may be a slightly simpler way to do this where you don't have to do it k times.
Mm-hmm.
You could maybe start on like a shoreline and maybe do like a perimeter search around the shoreline, and for all the cells that are adjacent to that, you count them as one, say.
Mm-hmm.
Then you go one ring in, and then you mark all those as two. All right,
Mm-hmm.
these are now the cells that are adjacent to ones become marked as two, and then the cells that are adjacent to twos on the inside get marked as three, and so forth. And so um, the number of islands you have will be the number of groups of cells that have a number greater than k, because any cell that has a number less than k will get eroded by the time k comes around.
Mm-hmm.
And so then you can do an island scan, and your island is the same as the island scan I described at the very beginning, but
Mm-hmm.
instead of 0 and 1, you're looking for like values greater than k. So you would any group of cells that are adjacent to each other that have a value greater than k will be an island that survives past k days.
Mm-hmm. That sounds pretty good. Um, what
That's a
does
thought.
the yeah.
So I'm imagining you could do this in, let me think about this for a second. If I were to, uh, this is, um, I think you can do this like ring perimeter walk in order and, or order, say the size of an island is I. You can figure out the distance from the shore per cell in order I time. And this perimeter walk is a little weird. I think it might cause some problems. Uh, you might be able to do something with like a breadth first or depth first search, perhaps, where you have, well, you don't know where you're going to start. That's the thing. It's not like you can say find the center of an island. That's a little tricky as well. So then you could try and do like some kind of, mm, what would be a good way to walk up from the shore and like hug the shore? What kind of exploration would that look like? Let's say you do a linear scan using all zeros and then you find a one. So now you know you're on an island. You also know this is adjacent to the ocean because you're linearly scanning. So you've
Mm,
just were on an ocean and you've touched land. So you know this is a shoreline and it's marked as a one. Um, and so how do you follow it? How do you sort of hug the left, let's say, and do a
mm,
if you were to hug your left side, you would do a clockwise walk around and stay as close to the ocean as possible. It's a bit strange because you're only going up, down, left, right. So if
mm,
you wouldn't actually be able to do this, for example, you wouldn't be able to do it as like a ring walk trivially. For example, let's say you have uh this example here. Sorry, 1, 0, 1. Oh, 1, 0, 1, 0, right? And you do your linear scan starting from here, and then you end up here. Um, you would go down. You would go left. You could check left, right, and then you'd have to go down, and then I guess you could check if hmm. So all the cells are marked one, which is not giving us any particularly useful information at the moment because it would be cool if maybe they had different values. Say, let's say, um, mm, hmm, can I do something like the average or sum of my adjacent cells or something like that? Let's say for a given cell, for this, oh, this is interesting. So for this cell, if any one of these happen to be zero, then this would, you know, be a one. But since all of these are one, this becomes a two. This is what we end up with here.
mm,
Um, the reason I know it's a two is because it's surrounded by one. So even if it had another two here, say, and a one here, something like that, uh, um, oh, I think I'm getting somewhere. So it's like a cell's value is plus one the min of its adjacent uh, uh the cells k, I guess, or cells innerness, like how inner it is
mm,
the min of is one plus min innerness of all adjacent cells. Um, does that seem right? Am I kind of on the right track here
mm.
with this thing? Maybe not. No, let me think about it more. So, um, is this plus one the min of all adjacent cells? I mean, in this case that I've drawn, it is, but maybe I could draw something different, right? What if we had uh something like this? I guess this, there's not really, these are all going to be one because they're all on the shore. Um, that's not that interesting. What if I had something like this? Um, uh, right. So this is technically an island. All of this is one island because they're all connected. Oh, well, this one is not. Let's say it like this. So this island has like a pool of water in it. What do we do about that? That's an interesting case. Is that something I should be concerned about?
Yes. Actually, that
Yeah.
does look like this example.
Which one, sorry? Are you near the top here? Yes.
Yeah, look with the
Yes, it
pool in
does.
it.
Yeah. It does look like that example with the pool in it. So, um, so the pool is also eroding everything around it. That makes sense. Okay, cool. So the pool isn't treated any differently. It's also ocean, basically.
Mm-hmm.
So it would erode similarly. That's good. That's good. I think that keeps things more straightforward. So maybe this min innerness thing is not that useful. I was thinking maybe it's like a dynamic programming where I have this sub problem of like min.
Mm-hmm.
Um, I won't. Maybe I'll put this in the maybe not down here. And then maybe this ring walking thing that I was talking about earlier. Maybe that's more like on the right approach, where I'm kind of like walking and every time I explore a new cell, if it's a land, I can like check the adjacent cells around me and then make a decision based on that. Um, well, if it's not just what the value of the cell is, it's also if I visited it or not, I think. Well, no, that's not quite right either. Hmm. I think if I do a linear scan, find the boundaries of all the islands and mark them like with the different numbers or something like that, so that I can know that, because what's tripping me up right now in my mind is you can't, when since they're all marked as one in the initial state, you
Mm-hmm.
can't necessarily use that information since there you can't tell off the bat. If let's say instead you had your oceans were marked with an enum for ocean and your island cells were marked with an enum for island, then maybe I would like copy the map once in n by m time,
Mm-hmm.
and I would uh, then I could choose um, then I could leave the ocean could be like infinity or nan or like max int or I don't know,
Mm-hmm.
some
Yeah.
-1 or something that would like really separate it, and then I would um and then all of the unvisited island cells would be some other enum, and then when I hit the an island cell, I would mark it as one because I know that I've linearly scanned. I know it's adjacent to the ocean, and then I
Mm-hmm.
can explore outward, and if uh if it's unvisited, I can add it to my queue or stack, and then I pop it off, and then no, I don't think that's helping me at all, actually. That's an
Mm,
interesting thought, but no, was I on the right track there
I
somewhat?
yeah, I do think you it is help like it is hard to store this information in the same grid in place, so I think you're right that
Hmm.
this is helpful.
Mm-hmm. Maybe useful. Copy the grid, represent it differently. Um,
And I think you're like I think calculating the perimeter how you did is helpful.
like the ring
That
search
makes
type of
sense.
concept.
Yeah.
Okay, cool. Okay. How would I Hmm. The reason I'm hesitant, I
Mhm.
appreciate the hint. I'm just trying to figure out this tricky bit here where you have this
Mhm.
sort of, jagged edge. I want to be able to um uh I want to be able to mark this as a one, and then, oh well, let me copy it first. So when I copy this over, uh copy it into my new data structure of some kind, uh oop, we'll call this one. So this is we have an ocean cell, which is a O, and then we have a land cell. Oh, wow, this looks like a zero and a one. That's funny.
Hmm.
Um, um, something like this. And so what will happen is I do my linear scan, and I get to this O, I get to this L, and I know right off the bat that I'm on adjacent to the ocean, so I mark it as such. And let me copy this. Oh, make sure. Oh. So then from here, now, this is the interesting bit. I want to explore the ring. So if I were to check my left adjacent, I would say that's ocean. I'm not going there. Up, there's nothing. Right is ocean. Down, that's something I can explore. Um, and I could, if I were to try and explore diagonally, I think it would just confuse things a bunch because, well, would it? I think so. I'd rather
Mhm.
not explore diagonally, I think. Um, so then when I explore this cell, I put it on the stack. This is the only thing I have on the stack. Or queue, and then I pop it off, and so now I'm looking at this one. I'm contemplating it. How do I know what it is? Well, I know I have land on this side and land on this side and land on this side, unvisited lands, and I have a one. Um, and I only have lands. So that means I can, it's the minimum of the minimum of the visited adjacent cells plus one.
Mhm.
No, that's, oh,
Mhm.
I think so, actually, yeah. The minimum of because suppose there's actually like a bunch of land here, right? It doesn't actually matter because I came from this, so kind of greedily, I got here first doing a DFS. And so even if there's like hella land over here, oh, but what if I got, see, what if I get here, what if I actually got here from here, say? What if this is actually a four, right? And I've been like doing like a depth first search or something, and there's like a I have it's hard to draw this vertical line, but above this I have a narrow isthmus of like one, two, and
Mhm.
three with ocean on both sides. So I have one, two, three, four, and then I get to this cell here, and oh, that wouldn't make sense. These would all be one because they have ocean next to them. There's no way this
Mhm.
could be a four. That literally doesn't make sense. Okay, okay, okay. So I think what I was saying makes sense. The shortest path to the ocean
Mhm.
is going to be what sets your number. Any longer path to the ocean is irrelevant. So by
Mhm.
doing
Right.
kind of like a greedy uh, depth first search type of strategy, I am greedily incrementing the adjacent cells. Um, and even if okay, so let's go back to what I think I'm on the right track actually. So this
Mhm.
I'm back here. I'm considering it. I have unvisited cells on either side and a one above. So I'm gonna mark this as a two. Then um, let's say I went down. Yeah, I could have gone left. I could have gone right, but let's say I went down. If I had gone down first, because we don't know what orientation we're going to be in, right? It's not obvious that will be oriented this way. So if
Mhm.
I happen to go in this direction first, I'll look at the adjacent cells. I'll immediately see ocean, so I know this is a one. even though this is a two. Um, then if I happen to go to the this side first, same story there. Now, if this were, let's say this was a land here, and this was a land here, and this was a land here, right? When I approach, and then maybe let's say this is a one, and this is a one, then when I get to this two, and I explore to this side here, I would say I have an unvisited cell on this side, a one, and a two.
Mm-hmm.
So I'm going to call this a three. So
Mm-hmm.
is that right? No, because
Oh wait, yes, yeah. With this ocean, yeah, or with this grid.
no, unfortunately,
Wait.
because this is a one, right? So then this
Oh
can't
yeah.
be a three. This has to be a two. So it wouldn't. I would look at. It's not that. Yeah, I would look at the minimum value of my visited adjacent land cells and increment by one. Does that
Yeah.
make sense? I think I was
Yeah.
on the. Maybe this
Yeah.
was right. Minimum of visited adjacent lands is one plus the minimum of visited adjacent lands. That seems to make sense to me, but
Hmm.
if you
Yeah.
earlier
Yeah.
you
I
thought maybe this
yeah.
wasn't right,
I
or maybe I
think
didn't explain
you
it
were.
clearly.
Yeah. Sorry. I think I thought this was different, but this makes sense. Yes.
Okay,
I
cool.
think you're.
I'm glad
Yeah.
I walked through
Yeah.
it.
Sorry about that. Yeah. I
No
think
worries,
that
no
this
worries.
makes sense.
Yeah. Cool, 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 cool. Um, so before I jump into, well, how much time do we have left? I've spent a good amount of time. Maybe we
Uh,
should talk.
I think
Am I
you.
doing great?
Yeah. Let's see. You have like uh 8. Let's stop at the 45-minute mark. So I think we still have
Okay,
plenty
cool.
of time. Yeah.
Cool, cool, cool. So then what I want to do right before I jump into coding, a little bit of pseudocode is always helpful.
Mm.
Because especially because we're doing C++, it can get hectic. So what we have here is first maybe a linear scan. This is like the outermost loop here. Um, and well, first actually we have a copy. Oh, actually, do I need to copy? Yeah, I think it's useful to copy maybe just um hmm. Yes, I think it would be useful to copy so I can mark the cell as visited instead of having to track a visited set. Or this is a C++ thing. If I wanted to make an unordered set of visited nodes, I would have to implement a point struct with or like a cell XY struct. Totally fine. However, to make it work with an unordered set in C++ is quite annoying. You have to implement like this like very complicated hash thing. It's not overloaded for you automatically, and I've never been able to successfully memorize how to do this. So I don't know if I want to do that in an interview. So maybe having another structure instead. So I might define my cell, copy into my custom matrix, which is going to be cells like this, something, n by m, and then my cells will be defined something like um, it doesn't even need to keep track of its X, Y necessarily. Or maybe I will, because if I want to pop them onto a stack or something. So it has a row, it has a column, it has a is visited, and then it has a is land. And then finally, there's a like like a mutable, like I will write the what should we name this thing? Earlier I was calling it innerness, then I could call it like distance from the shore or something, or
I think that's a good
um
name. Yeah. Distance.
distance, yeah, from shore. And if I get tired of typing all that up, I'll call it distance. Um, yeah, something like this seems reasonable. And then the loop, we have a linear scan, so that's going to be like a row, for row in rows, and then for cell in row, and then if cell is land and I and not visited also, then and do uh distance exploration for a given cell, let's say. Um, and then I also, so now let's see the def do dist x is going to look something like you give it to the cell, and then also the matrix itself, the my matrix, we'll call it, why not? Map, whatever. And then um, if how's this going to work? So I have this max min visit adjacent lands thing, and I have a DFS. So what I'll do is the way DFS works, we'll do it with a stack. Um, you could also do it recursively. Do you have a preference on that
Um,
yourself, or
hmm. So
I think stack? Oh, sorry. Go ahead. Go ahead. Go ahead.
is that
I,
right? Like,
oh, I'm our. Oh, is that right? Meaning,
um, hmm.
or do I want
Like,
to? Sorry, let me think about it. Let me back.
um,
Yeah, yeah. So, are you asking if this portion here is not quite right,
oh no,
or
no, I think that's right. I mean, in calculating the
so?
distance, was that DFS or was that actually BFS?
Let me. That's a good point. Um, that's a good point. If I were to do a DFS, I would have. Oh, yes. Um, there's a problem with DFS, and I really appreciate you for pointing that out. With the problem with the DFS is you kind of go in a straight line and you just kind of like explore in one direction, and you're doing the min of visited adjacent lands, and all of the adjacent lands are unvisited, so you're just like um
Yeah,
adding one, two, three, four, and you're
I
like
think what you
updating the
happen to
number, but
be, yeah, what you happen to be doing was BFS. I
a
think you
BFS. You're
just
absolutely
said
right.
DFS. Yeah,
So, perfect, perfect, perfect. Thank you, thank you. So
yeah.
we have a queue then. We need to have a queue. This is the frontier. I'll call it frontier, uh, and equals cell. Maybe I'll do cell dot dist equals one, uh, cell dot, well, I'll mark it as visited in my loop. Um, then while frontier, if cell, no, then I'll do cell dot visited, and then here's another function I need to write is this is a min adjacent dist function. This is going to look something like um so for the adjacent seeds, I have some kind of uh this is to the right, this is to the left, and then, or this is up and down, sorry, because you look up a row, look down a row. This is to the right, and this is going to be to the left. Um, and so I like loop over these, uh,
Mhm.
adjacent equals these, and then for adjacent, I then, loop over these, so just loop over adjacent, uh, add adjacent to cell, bounds check, if it's in the matrix, don't try and exit the matrix. So that would be like greater than or equal to 0, less than or equal to cell, to less than or equal to matrix size, uh, height and width. Uh, we would do a is um, adjacent, uh, if is adjacent visited already, um, then ignore it, skip adjacent that are visited, and skip adjacent that are ocean. Oh, sorry. Well, I'm not skipping here. I'm actually doing a min here. So, um, um, into my, uh, I need to have a small array here of values. This vals equals a little array, and then if adjacent is not visited and land vals dot append, um, and if it's ocean, I do need to be aware of that as well. If it's not visited land or ocean, so I'll append zeros in here if they're ocean. If it's unvisited land, I ignore it, and if it's a visited land, I will mark it as such. And then you know what? Maybe I don't care to mark the ocean cells as visited. Um, I don't think that matters since I'm just going to linearly scan over them anyway. It doesn't affect the order of the whole thing. But yeah, once I do that, then I can do uh, loop over min adjacent distance. I'm going to return after this loop. I'm going to return, and then this val is going to be defined up here, actually outside the loop. Return 1 plus min vals. And then so while frontier cell, if mark the cell as visited, um, um, then I want to add adjacent unvisited lands to the queue. So we would use a similar thing here to, look at all the adjacent things and add them to the queue. Um, and I will do this cell dot dist equals min adjacent dist cell matrix, something like this, I think. Let me walk through this once. We
Mhm.
have running out of time, so we need to be a little
Yeah.
bit quick here. Um, so copy into my custom matrix, cells, linear scan, um, do distance exploration. So this is let's make sure the depth first search makes sense, right? So while the frontier has things in it, uh, call this frontier, add adjacent unvisited lands to the frontier. Then for the current one that I just visited, I do this min adjacent thing. And yeah, I think this is it here. What
I
do you think?
think yeah, I
Am I
think
missing
so.
anything? Cool, cool,
Uh,
cool. All right.
yeah.
Cool. Okay. So then let's get into it here. Um, what I'm going to do is I'm going to define my struct. So if I stop talking for a bit,
Oh,
I'm
sure.
just
Yeah.
thinking right now. So we'll say, oh, 0, call 0. Um, who is visited all? Uh, um, who is land? Um, and then dist, sorry, int dist equals 0. And is there anything else I was missing from the row is visited is land dist. And then I'm also going to, make myself a little helper function here, static. I'm not going to do outside. I'm going to call using matrix equals vector int, oh, sorry, vector of int. Um, so that's just because I don't like typing vector of int over and over again.
Mhm.
This is the input matrix, and then using my mat matrix is going to be equals vector cell. And oh, vector is not included. And this should be at the top of the file, but I'll just do it here for now. And so now we're gonna do a let me stub this out for now since I'm running out of time and I want to focus on the more interesting bits. But we have a matrix, copy, input matrix. This is going to const matrix, input raw matrix. I'm going to copy this into, you can imagine it's like two nested for loops, two nested loop init cell and init cell with row and column. There's also some like you do like a std fill or something like that. You get your various C++ things to deal with the matrices. It returns a nice matrix for us. Um, and then so we have our matrix, and then let me maybe write this. Um, this part is interesting. It's worth writing down. I will do this. What I will do is I will additionally define a another struct. Oh, sorry, where am I here? I am. This struct is adjacent or uh hmm. You know what? This might be a little bit easier to do, and I kind of want to actually write this code myself. So what I'll do is I'll call this a hmm. I didn't make these. I should have made these unsigned ints first of all. So let me do that, and then I will actually define this as a separate thing because I do prefer that. This is adjacency, um, and this is an int, and it'll be row and int call also, and then what I'm gonna do is I'm gonna have an array of adjacency that has 4 elements. These are the adjacents, and this is going to have a 0 or 1 comma 0, uh, oh, negative 1 comma 0, 0 comma 1, 0 comma negative 1. Okay, so then I can loop over the adjacents with something like this.
Mhm. We can go over to the 50 mark.
Okay, thank you.
Yeah.
I appreciate that. Okay, cool. So I've got my array here. I'm going to loop over it. It's complaining about something that I did in here. I wonder what it is. Saying suggest braces around illustration of subject. Fix available. I'm not sure what it's mad about here, but I will leave it as is because it's some kind of simple C++ syntax error that should be fixable with relative it should be easy to fix, not a real algorithmic thing here. Um, okay, cool. So now the interesting bit. Let's loop over. Let's do this min adjacent disk, the innermost part, and build up from that. So I have a uint min. I'll do camel for you. Min adjacent disk, and this is going to take a const cell and a const my matrix, not the input one. Uh, and what we were going to do is let me actually copy my pseudocode down here so I don't have to keep scrolling up.
Mhm.
So what I'm going to do is Windows can't hide some of these panels. So I'm like I have a very small
Yeah.
viewport here, but so here, let's see, min adjacent dist. What I'm gonna do is I have my adjacency, so oh yeah, values. So I'm gonna make a small vector of uint, and I would use like I would actually do something like this in like real code. I just want to point that out.
Mhm.
This is not really uh, good practice here, but just for the sake of this vector u int dis or vals, we'll call it, since that's what I was calling it earlier. Then for const, uh, what did I call this? Add in in adjacents. Nice. Um, if we'll call this cell equals uh it's actually going to be constructed, and it's going to be dot row. This is also not ideal syntax here. I apologize again. This is a bit of a abusive notation, but I'm just going to do it for the sake of this interview. Dot row plus add dot row. Um, and dot call equals cell dot call plus add dot call. And now we could do our bounds check. So since I used unsigned integers in the cell, this makes the bounds checking slightly easier. What I can do is if adjacent cell, I don't have to check the zero case. I just have to check if it's greater than matrix dot size here, or if uh, because it overflows. If I
Mhm.
got a less than zero, it'll overflow to be a gigantic absurd number. Um, and if the adjacent cell is greater than matrix zero dot size, um, then uh, continue. We were out of bounds. Don't bother with this one. And if it's not visited, if it's not visited and land or ocean, then we will append. If uh, matrix adjacent cell dot row matrix uh, adjacent dot cell dot call, sorry, not dot. And this, I'm gonna rename this to like um, possible cell. Um, Let me do this. This is not correct here. It's a little bit, it's getting ugly there. Cell, the const, because I passed in a const thing, the const amp. Uh, this is the actual adjacent cell. Oh, it shouldn't be const. Oh no, this is const. I'm not editing anything here. If adjacent cell equals matrix, um, possible cell dot row. Oh, I'm sorry. Possible cell dot call. Okay, that's a little bit more readable. If adjacent cell dot is land and uh not oh sorry and adjacent cell dot is visited both there
I
val
I do think actually it would be better for us to talk about feedback now rather than
okay
continuing here.
sure
Yeah, yeah, yeah.
yeah
So
yeah yeah
let's
thank
stop
you
here.
so much
Yeah, of
thank
course.
you
All right. So, um, hmm. Uh, I think I do have a question before I continue with feedback first. Um, is your upcoming interview like it isn't in C++, but is that an option, or is this like, or is that,
It's
do
not
you
an
prefer
option,
that?
no.
Oh, okay.
It's not.
Interesting.
I would much rather be doing this in Python. I mean, I write C++ code every
Interesting.
day, but they
Yeah.
were very serious. All of the self-driving car companies I've interviewed at, and
Mm-hmm.
robotics and platform, every single interview last year I was interviewing, my current job that I interviewed for, the place that I'm really
Mm-hmm.
targeting, also they
Mm. Oh,
all
that's
require
so
C++.
interesting. Oh, okay.
Yeah, it's unusual. So
I've
this is not
had,
my,
yeah.
this is crazy. I agree. Look at
Yeah, okay.
how many characters I have to write. It's bonkers.
Right. Okay, I was just wondering. Okay. All right.
Yeah.
That's good context. Okay. Okay, so I actually usually ask uh candidates this. Could you do like a brief self review of how you think you did? And I just want to, yeah, I think it's helpful, for candidates to just hopefully understand how they think they
Yeah.
did, and then it matches how I think you did. Yeah.
I would say, I think if I had like 15 extra minutes to just code, I think I could have a pretty
Mhm.
decent thing working. Maybe 10 minutes even, maybe, But
Mhm.
the one good thing is I have requested an accommodation on time because
Mm.
my typing is really slow. I had to relearn how to type because of wrist pain.
Mm.
I have an ergonomic keyboard. I'm still,
Huh. Yeah.
it's a much smaller keyboard, so I don't have to stretch my hand out as much. So I will be given extra time
Oh,
during the
great.
actual interview. So I have an hour instead of 45 minutes for the whole
Cool.
interview. Um, yeah, you can see my typing is not very fast, and I think maybe I wonder if like, so on a previous interview, I got feedback that like, uh, I tried to do everything using just native C++ vectors and sets and tuples and pairs and stuff. And I got feedback being like, hey, you should actually try and define some structs, define some data structures. It makes it a little bit more readable. Uh, I'm sure if you've seen C++ code where, you know,
Mm.
it's all pairs and like it's like a set of vectors of pairs or something that it's so unreadable. It's like what is dot
Mhm.
first? What is dot second? That
Yeah.
has messed me up in interviews before. So that's why I kind of spent some time defining the struct up here,
Mhm.
defining this array so that I'm not looping over some like weird thing. Um, and I left this blank because I knew this is just like tedious, annoying C++
Yeah.
code. Um, and I figured if I get I got the skeleton of the um, breadth first search in pseudocode.
Mhm.
That's kind of the easy part. The hard part is kind of this like what am I doing the math on? What is the actual number that I
Mhm.
want to get and how do I want to set it? So I figured maybe let me focus on that. And so yeah, I think if
Yeah.
I had maybe 5 more minutes to finish this part and then 5 minutes to write the actual frontier exploration in the breadth first search, it would have been good. And then I think in terms of problem solving, I think that was good, right? I kind of
Mhm.
explored a few different options. I talked about simulation. I talked about I tried to go through a couple different paths, and then um, uh, there was a little bit of a miscommunication,
Yeah.
misdirection. We
Sorry
were able to
about that.
clarify it, which is no, that's not your fault. I think it's good that we were able to clarify it. I think that's actually maybe good signal as well on the communication side. And so yeah, and then um yeah, and then I think I came up with a few test cases to try and think through the problem, which is useful. If I had more time, maybe I would have had time to step through one of these test cases and like explore how it actually works. I would say overall probably like a okay, but not terrible.
Yeah.
It would have to maybe it would be up to the interviewer. Like some interviewers would be like, didn't finish the code, no hire,
Right,
and some
right.
interviewers would be like, "Oh, I like talking to him." So,
uh,
so yeah.
yeah, I think, yeah, so funny. I think, uh, like, I think I agree with like the problem solving there. Like, you did really well there. And then I think you did warn about, you did give me warning about going slow today. Uh,
Hmm.
and like, I think you're right. Like, you wrote out the pseudocode, and that was kind of the hard part. And then I think I can believe that you can write the code for this, for the
Hmm.
pseudocode. Uh,
Yeah.
and I think you're right that like there is probably room to go faster here. And I wonder what you would have done if you chose to to like flip it and like I wonder what your other mode is where you go really fast. Because
Oh, yeah.
what does that look like? You just spend less time planning or writing
Yeah,
pseudocode?
I wouldn't have written the pseudocode probably, and then
Oh, interesting.
I
Okay.
I think I mean in this case I kind of I lighted on the right approach up front, which is lucky,
Mhm.
and so I could have maybe just blasted through it, but more likely there's some trick somewhere I didn't think about, or like I
Oh, I
wouldn't have
see.
I would have maybe like gone with the DFS and then like run through it then, or like I
Yeah.
would have maybe, during this like +1 plus min, there would have been some trickiness where like I didn't think about like, is it visited, is it ocean? And I would have like coded
Okay,
up
I
something
see.
that doesn't really work.
Right, right. I think that right, like you mean the balance with correctness is quite
Yes.
important. Yeah.
Hmm.
I think I do agree with that. There is some balance. And maybe there is, yeah, maybe there is some in between between you going very fast and then
Yeah.
this process to do the planning. Like you did take a good amount of planning, and maybe some of that was like the clarification, like 5 minutes
Mm.
probably for clarifying what you
Yeah.
meant by the
Yeah.
interness. So um like that planning did seem good, and then for the time that you took to write some pseudocode, that did take a while. That was like 13 minutes. Um I
Mm.
I think that it was all like correct, which was very important and good. Like you did the like especially like when maybe this is an example like for the neighbors um traversal, like you made sure to check the bounds and then yeah, make sure you're visiting land or ocean or using the visited checks properly. That was
Hmm.
definitely important. Um man, I don't know. Yeah, I think that there is some balance here though. Like
Mm.
I ideally I think what your plan was is like yeah, you have the pseudocode and then translating it is fast. Um mm, but these checks just took quite a
Yeah,
took
there's so much
quite a bit of
typing.
time.
Yeah.
Yeah, there was a lot of
Yeah.
typing, which is why I was wondering about the C++ thing. And then, yeah, like you did
Yeah.
spend a considerable amount of time that you've also pointed out in to define the types. Like I think
Yeah.
you understood that took some time, but you
Yeah. Yeah.
also have a reason for doing that.
Hmm.
Um, I mean, okay, so I took some like timing for where you are, and it that is really great that you have an accommodation for more time. Um, um, I think you ended up spending most of the time writing pseudocode and code, though. Like 16 minutes
Mm.
planning is kind of reasonable. Maybe it is
Mm.
closer to the maximum of like 20 minutes.
Mm.
So maybe there is an opportunity to go like just a little bit faster in the planning, and then in
Mm.
the writing. But I think most of your time is spent writing pseudocode and code. So um, if you can find a better balance, uh,
Yeah.
because with an hour, then uh, that's
It's like 5 minutes
pretty good.
intro, 5 minutes
And then
for questions at the end, maybe.
yeah, so that's 25 or 35 minutes to write
Mm.
code and pseudocode.
Mm-hmm.
I guess that was
Uh,
doable,
yeah.
maybe. Like, when did you start? At 27. I guess you might have time to finish. So I don't
Okay.
know. Yeah, I think.
Yeah.
I mean, yeah. The thing is, like, when we stopped, I believed you. Like, I think you can write the code for this
Yeah.
pseudocode. And then it's
Yeah.
just about the testing, having time to test too. So,
Right. Right. Right.
um,
I
yeah.
know. You know, I'm choosing to put myself in this position where I'm like targeting these like super like popular companies, and I
Right.
understand that like I'm there's gonna be some like I have a family and I have a full-time job, and I'm competing with someone who is just grinding lead code at 40 hours a week. So it's
Right.
gonna be tough.
Yeah.
But
I
I
think
just
that
have to
you're
be
fine.
myself, I think.
Right. Right. Yeah. Like, the problem solving is really sound. So just the second part of the writing code is just difficult. Like,
Yeah.
I think it sounds like you've done the preparation you need,
Mm.
um, and just practicing how to find the balance between writing the pseudocode and code faster in C++ is
Yeah. Yep,
tricky.
yep, yep.
Okay, cool. Anything else I could help with?
No, I really appreciate that. I think I'm glad that the feedback has been sort of consistent. It matches with my internal model, and at least I have a kind of an understanding of where I'm at. And practice, practice, practice. Yep, that's got to be the name of the game. And hopefully, I don't know if is there anything else you think maybe was there some other like very minor thing you noticed that maybe you worth calling out, or something to consider?
I wrote down a lot of notes about the details. So
Okay, cool,
I
cool,
don't know if
cool.
there's anything there worth sharing. I mean, I think you're right. Like, you are pretty self-aware, which is really good. And then, yeah, just figuring out how to either, yeah, practice and write
Yeah,
code faster would be the
yep.
best improvement. All right. Well, good luck with your interviews. Great working
Thank
with
you
you.
so much. I
Yeah,
really
take a,
appreciate your time. I
of course,
know,
yeah.
it's very grateful that anybody would be willing to do this to help others out. It's really nice, and thank you. Like you're a
Yeah, of
good
course.
person.
Yeah, really good luck in your interviews. Looks like you're doing great. Yeah, take care. Have a great rest of your day.
You too. Bye bye.
Bye.